All right, so I'm going to be doing my presentation on the water balance of kangaroo rats, or the subfamily Dipodomys. So this subfamily has the uncanny and well-known ability to live in extreme habitats thanks to morphological and physiological adaptations. So the adaptation that I'm going to focus on is the water intake, the water economy of these kangaroo rats. So the first thing we have to look at is the field metabolic rate, of which they have 40% lower than mammals, eutherian mammals of the same size that don't live in the desert, which means that they have a diet that is 60% less than those same size mammals. And this is linked to a basal metabolic rate that is also way lower than those same size mammals at 75% lower. So the next rate we have to look at is the water intake rate, which pretty much says that these kangaroo rats, for non-desert mammals, they consume only 59% of water that non-desert mammals take in, and 75% of desert mammals. So they pretty much saying that they require, so their water requirement is much lower. And so these two rates are the proportion of the water economy index. And the average one for these kangaroo rats is 0.071 milliliters kilojoules to the negative first. So pretty much what this means is that this is higher, like way higher than they projected. I think they projected it to be at about 0.045. So that's way higher than they projected, which means that they obtain more water from their environment than initially thought. And they do this by having the ability to detect the amount of water in seeds. So they hunt for seeds that have more preformed water and have higher metabolic rates. So they have this uncanny ability to annually need less water. Therefore, they don't drink water, and they live and reproduce without drinking water. Now, this water is going to become more scarce as climate change occurs, and so we're going to look at how climate change is going to affect the survival of this species. So in this area right here, the temperature yearly right now is 45 degrees Celsius, and the survival is 0.45. Now, in this area, the temperature is 50 degrees Celsius, and their survival is 0.3. And lastly, in this area, the temperature is 40 degrees Celsius, and their survival is 0.65. So in 2099, temperatures are going to increase by a maximum of 6.5 degrees Celsius. So in this area, they're projected to increase by 4.5 degrees, and this will bring down the adult survival rate to 0.15. And then this area is going to increase by 4.5 degrees Celsius as well, and it's going to bring it to 0.30 survival rate. And then this one's going to increase by 6.5 degrees Celsius, and it's going to bring it down to 0.5 survival rate. So this is really plain to see that these temperatures, and this is looking at the summer diurnal surface temperature, is really going to affect the survival rate of these animals that already live in extremely arid climates. And it's something important to look at how climate change is going to affect species that already live in areas of extreme climate conditions. And yeah, I think that's it.